Conference, your source for JVM knowledge.
Morning. I can barely see most of you because these lights are really, really bright. Anyway, so thank you for being here. I know it's a bit early in the morning. I hope that you have some coffee. And hopefully today I'll have some news for you about what's going on in Gradle. But before I get started, how many of you are using Gradle 5 already? Just a few hands. Okay, so that means that most of you are using some version of Gradle 4 or even Maven? Yeah? It's okay. It's all right. Well, so the point of today is to show what is new in Gradle 5 so that my point is to get you excited about these releases. We just released 5.3.1, I think 2 days ago, and 5.4 is coming pretty soon. And there are many things that we are excited for. So this is the current agenda that I have for today. And yes, I know, this is it started as a Groovy-based conference, but we have to talk about this guy, the Kotlin DSL, because there has been a lot of improvements happening in the Kotlin DSL arena. Now, who has already tried out the Kotlin DSL? In version 4, 5, and it kind of works, right? Well, let me tell you that in version 5, things work much, much better now. So, yeah, little elephant. And, oh, I almost forgot. So you see, this is the grumpy elephant, but we have a new logo, and I forgot to bring the new T-shirt. This is still the old T-shirt. And we have some stickers with a new elephant, so but when we finish the session, first come, first serve, only a few ones. All right. So we got a new logo, but the thing is that the Kotlin DSL benefits, the idea behind offering the Kotlin DSL is that Kotlin is a statically compiled language. So given this, the IDE should give you better tool support. Now this is true if you use a certain series of IDs, and we'll get that into a moment. So you get auto-completion and content assist and refactoring, everything that you have come to learn from static compiled languages. The quick documentation is also true because you have access to the well, Java doc or Kotlin doc to any of the classes and properties and methods that you're used to. So again, the IDE should give you everything that you want. Now, in 5.0, we released Kotlin DSL 1.0, so it's ready for consumption. And in version, I think is 5.2 was also released early this year. We have now the Kotlin DSL 1.1, and in just recently in 5.3, we released we upgraded the internal Kotlin library to 1.3.21, I believe. It's not the latest one, but we are pretty much up to that. Now, the question will be, should you adopt the Kotlin DSL? Well, this is kind of act as a laundry list of things, of checks that you have to cover to make sure that you really want to do this. First, are you already using Gradle 5? If you are, then moving to the Kotlin DSL, it's much, much easier. You're using the plugins block or the build script block. So you might remember in the old days, like 5 years ago or so, we used to use the build script plugin block, to define how you configure plugins that are going to be applied to your script. You can still do it. It's known as the old school way. But since Gradle 2.1, we have a new version, which is the plugins block. And this allows you to define just the IDs and the versions and a couple of properties, perhaps, and simplify things a lot. Now, I really love using the plugins block versus the build script. There are some cases where you still have to use the build script block, and so you just have to be aware of. So if you have already migrated to the plugins block, the Kotlin DSLs make it much, much easier because those plugins that are coming from core, you only need to specify the name or the ID of the plugin. You don't even have to specify the ID method as you would do in the plugins block in the Groovy DSL. So a tiny bit of advantages there, but it makes it a little bit easier. The next thing is, does your IDE support Kotlin? And this is the tricky question, because not every single IDE will give you all the benefits that you expect from a statically compiled language, and we'll get to that in just a moment. Are you also familiar with the Kotlin syntax? If you are not, if you are okay with Groovy and then say, oh, let's give it a try to the Kotlin DSL, and I will expect my IDE to give me all the benefits out of the box, you will not get it. You have to know a little bit of Kotlin in order to get started. Otherwise, it's not going to work. But you can learn. It's not that problematic. And we have a migration strategy that the slides will be available and online, so you can click on all the links that I'm going to show you. So if you comply with all these checks, then sure, go ahead. Just continue going with the Kotlin DSL. So here's a list of at least the IDEs and rich text editors that we keep tracking of. If you're using IntelliJ or you're using Android Studio, you're good to go. You have all the benefits. The semantic editor, which is the one that's going to give you the content assist and refactors, all that, this just works, or we expect to work. If it doesn't work, file a ticket with JetBrains. For the other IDEs, well, the only thing that you get is syntax highlighting. So the benefits of having a static compiled language for code completion and whatnot, well, we will spec those IDEs and those text editors to at some point give you some sort of support, but right now it's up in the air. All right. So if you have already tried and you were disappointed, give it another look, because it's much better. And we always welcome your feedback. And if you encounter any problems, please let us know. That is the URL for you to file a bug. Please do so. This is how we can make things better. And we also have a guide detailing everything that is available about the Kotlin DSL. Here's the URL. And if you have any other questions on that one, just refer to that guide. And if it doesn't solve all your problems, if it doesn't solve all your questions, then also come back to us, give us your feedback, and we can make things better. The next thing is build performance. And with this one, we are definitely much more excited, because one of the things that we would like to do in Gradle is make sure that you have better developer productivity, so that you are not wasting your time and then you just are concentrated on doing the task at hand instead of battling with the build or battling with the build tools. The build tools should be there to aid you, not to be an obstacle for you. So in the several releases, what Gradle has been doing, the Gradle build tool, is making things faster and faster and faster, and we have added a couple of APIs to make this work. Now, what these graphs are showing you is a typical, well, kind of like a typical Java project that has 1,000 modules. My projects usually don't have more than that, but imagine if you really had a really big project, whether it's a monorepo or not. You probably know that Gradle works in a mode that first it configures your project, so it takes some time to figure out what needs to be done, and then comes the execution phase, where it's actually the work being done. So when you have such a big project like this one, configuration can take some time. And we have done is try to reduce the amount of time that it takes for the build to get initialized and configured. One of the things that we would like to do is to reduce this time to 0. This is the goal. Well, we are not there yet. We will eventually get there. So you see that with Grails 5, we have reduced around the 20% from the past. Well, and that is a configure one. But what we're doing here is the incremental compilation of Java projects. Now, this is something else that also makes your things, makes your project faster. Because what we do with incremental compilation is that we try to identify not just necessarily which task, but we go all the way to the source file, the individual one, to figure out if that particular source file has to be recompiled or not. If it has any changes, it's going to be recompiled. If it's not, then it's just left alone. And we do this by calculating what is known as the binary compatibility API. If you change the name of the class, rename a method, or change the method signature in some way, and it's a public method, that means that the API compatibility will be changed. Thus, we have to recompile. But if what you do is change the contents of the method, how it is actually implemented, or you're changing a private method, then we don't care about the API. You can change all implementation details as much as you want, but because you did not break the contract, the API from the whoever is consuming, so producer consumer, then there's no need to do some recompilations. Now, I will say that at some point, you might want to recompile the whole thing, because even if you change the implementation details, there may be something in the contract. Maybe the method is slower, and your whole system has an SLA that it cannot be, that a response cannot take more than 15 seconds or milliseconds in order to respond. So if you make your implementation slower, then your test cases will say something is wrong. Where your API will still say, I am fine, I'm returning the thing that I'm supposed to be returning. It's just that it's not in the appropriate time. Anyway, in order to make this happen, if you have mixed sources, so if you have Java and Groovy or Kotlin or Scala, all these things mixed together in one source directly. For example, you put Java sources inside source main Groovy with your Groovy sources, or Java sources in source main Kotlin. This will be a little bit of a problem for Gradle to determine where are the circles or the cycles within Java and Kotlin and Groovy. So in order to make the most of the API compatibility checks and the incremental Java compilation, it is recommended that you put your Java sources under source main Java and your other sources in source main Groovy, source main Kotlin, and so on and so on. Even though all these languages allow you to have like a joint compilation session, it is preferred that you split them. If you do so, then Gradle can do most of the work for you. There will still be some cases where you might need to put Java sources alongside the other ones, the other languages, because you are implementing a Java interface or calling code from Java, from all of these languages that were defined in Java. There may be some cycles that cannot be broken, but if you can, split. We also made changes in annotation processors, and that might have caused a few problems when people have upgraded from version 4 to version 5. We know that there are annotation processors that generate source code, and there are even those that change the bytecode, like Lombok. Any Lombok fans here? I'm a Lombok fan. Yeah, most people don't like it because it changes the bytecode. It's like harmful, but it isn't really. But the thing about the annotation processors is that because it generates new outputs, it will change and it will affect the up-to-date checks for the compilation task. So what started the work in the latest versions of the 4 series and then was certainly revamped for the version 5 series is to make sure that we have the split within when the annotation processor does the work that is done before the actual compilation step or your sources. So we are trying to make sure that when the annotation processor generates whatever it needs to generate, these outputs get also cached at the appropriate time so that you don't need to waste time recompiling and doing more work that you shouldn't be doing. Also, I failed to mention, when you have any questions anytime, please let me know. Composite builds is not per se a feature that is new to Gradle 5. It's just that some updates that have been posted very lately. The last one, I believe, was posted in version 4.10, or maybe it was in 4.10.1, so very close to version 5. It's called nested composite builds. Now, if you have not seen this before, I think this is a really, really good feature, which allows a specific build, so build A, to have a dependency on build B. Usually, build B will provide an artifact for you, and build A will consume that artifact. Now, you found that when using the build number A, there is a bug in B. how do you fix this? Typically, go on this build, fix it, push the artifact, maybe make a release, and then test again. Or maybe use a snapshot dependency. But if you made a mistake by fixing this bug and you create another one, then you have to continue to fix and fix and fix. Now, it will be much, much better if you were able to test the fix of B alongside A, and once you know that everything is working correctly, then you can push the release for B and maybe a release for A. This is exactly what composite builds allows you to do. When you establish a link within the two builds and you compile A, it will detect if there are any changes in B, compile this, generate the artifacts that are needed, and then consume it directly. At any point in time, you also can cut the link within the two builds. Now, another thing that this feature allows you to do is that the secondary build, so B, could also have another included one, and another one, and another one if you want to. This is known as nested composite builds. This allows you to assemble something that looks like a monorepo based out of multiple repositories. So for those of you that have tested the ideas of monorepo and believe that it's a lot of work to move from separate repositories into a single one, and we're going to lose the Git history, no worries. Composite builds allow you to keep all these repositories separate, but working in all of them as if we're a big monorepo. Conversely, the other way around is also possible. If you are in an organization that is working in a big monorepo and that turns out for some reason to be a bad idea or is not giving you the benefits that you were expecting, you can break down this monorepo into smaller pieces. But you don't need to break down or to start to move the code base completely crazily and changing source files all around the place. What you can do is simply add new build files in all the different places that you need and establish a link for the different or included builds. So in this way, you don't have to git check out for many places. You can still have everything together, but the source files are in one place, but each one of these builds will be completely separate. And you can do cross-repository refactoring. That's the other idea, to have the inclusion within build A and build B. I have to say that since they added the feature for nested composite builds, this has become a really good thing to have. If you ever had the need of dealing with snapshot dependencies, I would certainly recommend you to have a look at this one. Next one is in terms of the build performance, is accelerating your build by making sure that you don't do the work that doesn't need to be done because you have already computed. So this is pretty much the build cache. You probably are aware that the early versions of Gradle, when you execute a task, Gradle computes what are the inputs and the outputs, and the next invocation of this particular task, in the inputs did not change, then it will going to give you the same outputs. So if it captures the output before, then it's just going to use it. The task is marked as up to date, skip, and then you continue with the next one. So this makes Gradle faster. But if you do a clean on this current build, then all these results, all these outputs get deleted, and you have to execute the task again. So the first level of making sure that you can do things faster is, what if there was a way for you to keep track of these results within different builds? And we do this using the local cache. This is called the build cache, which was added, I believe, as an incubating feature in Grails 3X. It was revamped in 4, and definitely in 5, we will recommend you to use all the time. And once you get used to running your builds with the build cache, and say your builds typically will be, I don't know, like 3 minutes perhaps, or 2 minutes. With the build cache, we can have this, and depending in some cases, it can even be less than that. So if you were used to a build of 1 minute, and with the build cache you get 20 seconds, you will not want to go back to those 60 seconds in the past. You really want to have those 20 seconds. So, and that's great for you as an individual developer. But what about your other teammates? What if you were able to share these computed results that were computed in one machine into another machine, even with CI, and this is what we call the remote cache. So Gradle gives you all these capabilities. You can configure just the basic one or enable the local cache or even the remote cache. It's up to you to figure out the strategy you want to follow. So here's an example of the build cache. On the left side, there will be an invocation of a task that does not use the build cache, the local one. And on the right side, it's actually the other way around, I think. There will be a build that makes use of the local cache, and the results have already been computed. So you see, it starts to work, there's use of the build cache, and that finishes in 1 second, because all the results were already done in that particular node, whereas this one is still doing the work. And you can enable build cache on the command line, just passing -- build cache, or you can set it up with property on your Gradle.properties file, whether it's local or your global Gradle properties file. You can say something like, I believe it's org.gradle.caching, and you set it to true, and this will mean that the build cache will be available for that particular project, or if you set in the global properties, it will be available for all your projects. In Gradle 4, that was kind of like an experimental feature. In Gradle 5, I certainly recommend you to set this property to true in your global properties and just reap the benefits of using the local cache. Another thing that we add a few years ago, but it is getting new features, is the concept of build scans. Who has done build scans before? Just a few hands. Okay, great. So let me tell you the benefits about build scans. Build scans are a way for Gradle to capture the build execution data, and then later you can analyze this. So I have here a snapshot of a project that I made with both Maven and Gradle, and I wanted to test and find out where in my build there were some hotspots or things that I can fix. Now that's an URL of a previous build that did not have the local cache. So let me show you now. I'm going to switch to the browser, and I have here 2 build scans of one project that I ran yesterday. One of the builds took 1 minute and 31 seconds. This was a full build, and nothing was cached before, so this is starting from 0. And the next build is exactly the same command. It will be clean test aggregate test report, and it took 5 seconds. And this was only using the local cache. Why? Because I didn't change any single input. All of the computations were able to be cached, or the ones that I care about. So that means that Gradle spent most of the time trying to figure out, do I need to do something? No. And then continue and figure out, there's nothing else to be done. I'm ready. So let me show you some of the things that you can do with build cache. Of course, there's a summary and a timeline of all the different tasks that were executed in your build, how much time it took, how many different tests they were, how many projects you are, and you can drill down all these projects, and how many plugins were applied, the switches, so you can see that I had the build cache on, and the Grail daemon is also on, and I was running my build in parallel. So I also got a little tiny amount of speed on that, and some information about the computer that I run, which is actually the same one that you're seeing here. If I look into the performance, and it will tell me here in the task execution that without avoiding all the code that I should not be doing, my build would have taken close to 5 minutes, but it actually was 1.5 minutes. And it tells me that of all the tasks that I executed, 50% of them are not cacheable, and 50% of them were. So all those tasks that are not cacheable, I can drill down to figure out, I don't have network. That's bad. Let's turn on I thought that I did not need the network. We'll come back in just a moment. I guess that if I click here, it might not work. There we go. Do it again, refresh. And if I click on not cacheable, it will tell me, oh, this is not that big here. There we go. There are tasks that are type delete. These, of course, destroyed outputs, so you can never cache these things. There are other types of tasks, such as process resources. These are copy tasks. It's much, much faster just to copy files from one place to the other than try to package the resources and then unzip again, because this is what the cache is doing. It saves the output zips and then dehydrates these things. The jar file, the jar task is pretty much a copy task or a zip task, so it does exactly the same. There's no point of caching these things. But this particular project makes use of protocol buffers. Protocol buffers, these tasks, protocol buffer extract might be something that stems from zip, in which case it's not cacheable, but maybe the generate proto task could be made cacheable. We have to figure out, and that's what the Gradle protobuf plugin will have to check. But the other thing that I wanted to show you is the hits in the build cache. Because when I ran the build for the first time, the cache tells me that I had 70 tasks that I missed that I could have cached, but I didn't. But when I look at the other one, this is the one that is very fast, and look into the build cache, I had 100% hits. That means that everything was cached on the first time was reused on the second time that I ran. And this is how we can figure out how effective your build was. And based on other information that you can see here, you can inspect dependencies, you can inspect, if there is a report on the test cases, so this one here is the lowest test case. Actually, that's a test method. So if I want to figure out where the slowness in my build is, where are my slow test cases, I can go directly here, go to the first one, fix it, run it again, and run it again. And if I'm making use of the build cache, making all these checks with the build scans will be faster and faster and faster. All right. Let's click play here. Here's another one. On that side, we got a test case that is broken. And because we specified the dash fail fast, the first test that fails, Gradle will completely stop executing the build. Whereas without that flag, there will be a test that fails, but Gradle will continue to execute the rest of the test suite. Now, this is great for integration test cases that take too long. So you don't want all the integration test case or the functional test case suite to finish to figure out, I had a test that is broken and everything else was fine. And maybe the test that was broken was the last one to be executed or somewhere in between. With the fail fast, as soon as there is a problem, it stops. And the next time you invoke the test cases, Gradle is smart enough to run the failed test first and not those that were already working correctly or that were green. So this, again, gives you back that time. And sorry, if you are used to just browsing the network for webcomics where the build is working, we're just taking that time out of you so you can be more productive. And you can watch later anything you want after finishing work much earlier. We have a guide on more things that you can apply to make sure that your build is more performant, to make it faster, to make it more reliable. And again, like the Kotlin DSL, if you have any more questions regarding this, please give us your feedback, and so that's how we can make things better. The next one, dependency management. Actually, there have been so many changes coming here. And the one, who here uses a Spring Boot? And the Grails Spring Boot plugin. You might have seen that there is another companion plugin called the Dependency Management plugin. This one allows you to define like a dependency management block like you do in Maven, so that you can consume something that is called a BOM, or bill of materials. It's a set of dependencies that are fixed or that come grouped in a set, and you are supposed to use those dependencies with those exact versions. So when you import dependencies in Gradle, you have to specify each one of them. But if you use the dependency management plugin, then you can say, I want to import the BOM, and all the dependencies, all the versions that are recommended can be used or can be applied on my build. Well, there are some differences on how this plugin is actually implemented. So Gradle 5 added better support for importing BOM dependencies, which makes it much, much faster again, selecting which versions you want to use. So if you can consume bombs, the next natural question is, how do you produce bombs? Well, in Gradle 5.2, I believe, we added the Java platform plugin, which allows you to define a group of dependencies that come together. Now, the platform is more than just a bomb, but the way that we express right now how you can consume the platform is through a Maven bomb. So it will generate a point file that looks like a bomb, and you just apply it and consume it just exactly the same. More things. There we have new Grails APIs, and the first one is something that people were looking or were asking us a lot, that what if there was a way to specify the timeout for a particular task. If it takes longer than X amount of time, then that task should be killed because it should not be happening. We also have something that's called the provided APIs for the properties. In the past, you have probably seen that tasks and extensions and even plugin conventions, which is very, very old, use regular getters and setters for the properties. But we now have property wrappers that can keep track of the values, and this will make things, again, work better with the caching. We have something called the configuration avoidance APIs, which I will show you in just a moment, but this basically what we're trying to do is what I was showing with the graphs earlier, try to reduce the configuration time as much as we can. So any work that should not be done during configuration time should be avoided, and that's exactly our aim. You can also specify custom CLI flags, and this is something that I really like, and I'll show you an example for that. And the Worker API, for those of you that were in the previous session with Scott, you probably have heard that the Worker API is not really there yet. If you want to use it in Anger, but it's something that we're definitely trying to make better, and I will show you an example of that. So here we have the first example. This is a plugin written in Kotlin. What's going on with the animation here? There we go. So this is the timeout. The task is of type test. It's an integration test case. The bunch of things that you see here is just configuring the properties for that particular type of test. What is important is this thing here. Now, tasks have a property of type timeout. This is the property wrapper. In the past, you will have to use the equals operator and apply the value. And here, we're just setting the value on itself. And if this particular task takes more than 5 minutes to be executed, it's going to be killed. So for some cases, you would like to do this. Here we have the compiler avoidance one. And what's going to happen is that there will be, come on, the animation. There we go. With this with type block, any task that is of type test will be configured with whatever is going on in that particular function, that closure. The thing is that that closure will not be executed until the time such configuration is needed. If you, there is another question, I think it might be registering, or it was in the past. When you create a task, you will usually do something like project task, create, give it a type and a name, blah, blah, blah. This will create the task eagerly. And this happens during configuration time. What happens if you don't need that task? Well, you just wasted time creating something that is not needed. But when you register a task, the block that is used for configuring will not be executed unless the task happens to be added to the task graph, and then it's going to be added. It's going to be executed. So the same thing happens here. It's only when we have to execute tasks of type test before they are actually executed, this block of configuration will be applied to them. So when we run the plugin for the first time and figure out what's going on with the configuration, that completed block is skipped. Here we have, this one is setting properties. So we kind of saw it with the timeout, But here, before, you had to use the equals operator to set the values for each one of the properties. Now, the only thing that we have to do is use the setters. And again, this will make sure that it has has calculated the right inputs and outputs as in the past. Here we're showing the Kotlin DSL, so you see the advantages of having an IDE that can give you the code completion, but it only works if you have an IDE such as IntelliJ for now. Next is the Worker API, and what we're doing is breaking down this task into smaller chunks, and we're passing that to a Worker executor. The idea is that this task takes a long time, or it's kind of like if I want to say something silly, like a monolith task, and we want to break it into micro tasks. And supposedly the Worker API will help us work in this way. So that Worker runnable that we had in the past takes X amount of time, and some portions of that task can be parallelized. And the Worker API will allow you to break down into smaller pieces. Some of those things that can be run in parallel will be done so, and those that will need serialized then will also work in sequence. And in this way, we can reduce the amount of time that your build takes. There are still a few issues with the Worker API, but we're trying to make it better. So please give it a try, and please give us your feedback. And finally, some options in the CLI. So here's a plugin. This one is a static Ruby. And what is new is that option annotation. You can set it on any method on any of your tasks. And if you follow this convention, you can give that about any name you want and some description. So what's going to happen is if I run Gradle help on the task that is created for that type, it will tell me that now I can set two properties. It's either section or sections. So when I type on the command line, Gradle, and the name of the task here will be effective settings, and then -- option, and give it a value, then that value is going to be applied to that property here, section. Or if I say -- sections, then this method is going to be invoked. If you've seen in the past how we can filter out dependencies by their configuration, so you say something like Gradle, dependencies, -- configuration, and then some value, runtime compile. This is exactly the same thing, but in the past, it was only possible for internal tasks. Now, you can do the same. So for plugin authors, this is something that is really good, let me tell you, because it's something I keep using every single day. Another thing that I like is, this was added, I think, in version 5.1, is filter out tasks by groups. So here's an example of a project that, let's make this bigger, like this. And this is the Sentinel project that I used in the past for the build scans. No, that's not the directory. That's the one I want. And this is a multi-module project that has lots of projects. And I want to know how many tasks I have for the Sentinel core project. So let's make it big here. And I run task. And this will tell me everything that I can invoke on this project. And it's a bunch of them, but I don't care about those things. I want to know only about the inside group. So what do? I can go here and say -- group and do something like this. I say inside, execute the build, and now it should tell me only about those tags. So this works if you know what is the name of the group you want to query. All right. Next one. Maybe I should have changed not so fast. Grail init has additional bootstrapping project capabilities. And let me show you what we can do. And this one, I think I can do it right here. Let's go there. Let's create a directory like this. And there have been a bunch of people that have created, that have complained and asked, where is the artifact or archetype support in Gradle. We don't have something like that. We have so many archetypes in Maven. How can you bootstrap projects in Gradle? There are some ways, but Gradle init allows you to do so in a very basic one. So we can call Gradle init here. And now we'll pop something like this. So you have 10 choices. And let's go with the Java application. And now it will ask me what type of DSL you want to use. You want to go with the Kotlin DSL or you want to go with the Groovy DSL. I'm going to go with Groovy. And now it will ask me, well, you should be doing testing, right? So which testing framework you want to use? Let's go with Spark. Let's see what happens. And let's use the default names for the artifact and the package. And there you're done. So this is what has been generated. So your build file, the wrapper, the settings.gradle file, a very basic main class, and a very basic test. And if we inspect the generated files, let's make this bigger. It applies the Java plugin, the application plugin, and Groovy. So this is what we're expecting. Defines a repository for resolving dependencies. It gives us some hints of what kind of dependencies you can use. So this one probably makes no sense. This one we want because we need a Spark for testing. And it gives the main class for the application. And boom, there you go. So it's easy to get started. All right, let's continue because we have a few more slides to go. This is another very, very interesting feature that is affecting Android users for some reason. Now, since Gradle 5.1, I believe is also the case, you can pin dependency resolution to certain repositories. There was the case that there were some repositories that have malware attached to the libraries, and that those repositories were being resolved ahead of other repositories for whatever things and how these things were configured. So now you can say that any dependency that matches certain regular expression or is a very specific group artifact version can only be resolved for that particular repository. So if there is a bad thing somewhere else in the outside world, it's Maven Central, JCenter, or something else, a public repo outside of your control, then if you know that you have the right artifact, you can put it in your local artifact or repository, whether it's Nexus, Artifactory, it doesn't matter, whatever it is. You can pin down resolution to those artifacts or groups or artifacts to a particular repository and make things better. We also have better searchable documentation in case you haven't seen the documentation lately. You can search all the Java docs and all the DSL, all the guides very, very easily. There is more information about what is new in Gradle 5 in that particular URL because I am only touching on the big features. There are definitely much smaller incremental features that you have available in Gradle 5. So for those of you that have not migrated yet to 5, definitely have a look at this URL, and then you can see at a glance everything that we have done so far. And of course, you can also consult the release notes for each one of the releases that we have posted. This is everything that I have for you, and I hope that it has given you a glance of all the things that we have done so far. We're quite excited of what's going on with Gradle 5. The build cache, it gives us a lot of time savings. The build scans is also a feature that I cannot stress enough how many benefits it have given us. So if you have not tried them, please do so. So with that, I guess thank you very much, and now we're open for questions in case you have them. Any questions?
We have time for a question. Two quickly questions. If I have plugins in version 4, is it difficult to migrate to 5? Compatible? Or?
We have tried to, so the question, well, yeah, it's on the mic. Was the compatibility for plugins going to 4 to 5? There have been some breakages going from one major version to the other. We try to make compatibility as much as possible. But the plugins that the most used plugins have already migrated to 5 or have been tested with 5. We have a bunch of plugins for which we internally do so. For example, Shadow, which is amply used in the industry. This is one of the first ones that feels the problems when there's something going on. If there happens to be a plugin that makes use of internal APIs, you shouldn't be doing that in the first case, but the fact that you can reach to it, then people will use it. Please don't. Try to find an alternative on a public API. If there's no such thing as a public API for it, please let us know. File a ticket, and that's how we can make things better. Other than that, I would say before upgrading, reach out to the authors of the plugins that you're making use and check if they have already made any claims of compatibility. If not, then just do a quick upgrade, run the build, and see if it's working. Sometimes it's the fastest way.
And the second question is very quickly. The bootstrapping option, you can make a Gradle ini or Gradle ini, the list of the I don't know, Groovy library, Groovy application.
The templates, yes.
The templates. We can add new templates, or only you?
Not that I'm aware of. Right now, this is only coming from the Gradle init plugin is internal. If you want to have your own templates, then I would recommend you to have a look at the project called Lazybones, which is the one that allows you to bootstrap any kind of project, even non-Gradle projects. Now, personally, I like Lazybones a lot because it gives me more room to work. I can create my own templates. I can have something called sub-templates or generate sub-templates. But the disadvantage is that you have to install another program, Lazybones. But I use SDK Man. Is Marco here? No? Well, then it's very easy to do so. So it depends on what you want to go. Okay. Go with the defaults. It's already there because Gradle provides the init, or you go with the secondary application, which means you have to learn a few more things, but once you do, you get other benefits.
Okay. Thank you.
Sorry, there's no time for more questions, so thank you, Andrés.
Thank you. Don't forget sticker.